Hey everybody, what is up? It's your boy, Mr. Math Teacher, aka the Mathemagician. Welcome back for another episode of How to Learn Math Today. Hey, if you like this video, you can pound that subscribe button down there. Mash that like button. Okay, who am I kidding? I will say though, I've always wanted to do that because that seems the way that all YouTube videos annoyingly start. I feel very cool now. All right, I'm ready. Here we go. So earlier this week, you were telling me how there are 3 different ways to solve systems of equations. Today, we're going to take a look at substitution. Now, substitution, ideally, you only want to use when you have an equation where one of the variables is isolated. That's always going to be the most convenient time to use substitution. For instance, on example 1 here, you'll notice that in the first equation for my system, my y value is already isolated and it equals 3x plus 7. So what I'm going to do is I'm going to take that amount and substitute it into the other equation for the y value. So that would leave me with negative x plus 6 times 3x plus 7, which would equal negative 9. Then I'm going to use the distributive property, so I'd get negative x plus 18x plus 42 equals negative 9. Combine my like terms. Subtract 42 from both sides. And so x will equal negative 3. Now, in order to figure out what y will equal, I'm going to have to take this guy here and substitute him back into one of my equations. You'll notice here that the top one looks significantly easier than the bottom one, so I will go ahead and substitute that in there. So y will equal 3 times negative 3 plus 7, which is negative 9 plus 7, which is negative 2. So my mystery numbers here are negative 3 and negative 2, and so here is my solution. Again, just so we're clear, this is the only combination of x and y that you can substitute into your equations and get 2 true statements. It's also the intersection point if we were to graph these two as lines. On the second example, you'll notice that neither of the equations have a variable that's isolated. So this is kind of inconvenient, and in most of these instances, I'm sure you'll want to use elimination. But because this is practicing with substitution, we're just going to kind of roll with it. So when I look at my 2 equations, the bottom one definitely looks like it'd be easier to isolate a variable. So on the bottom equation, I'm going to go ahead and isolate x. So x, therefore, would equal 11 plus 2y, because I added 2y to both sides. Just like the last one, I'm going to take this value here and substitute it into my other equation. Again, these are called systems because they have to work together in order to achieve a goal. So I'm going to rewrite my top equation here. 7 times 11 plus 2y minus 2y equals negative 13. This would be 77 plus 14y minus 2y equals negative 13. Combine my like terms would give me 77 plus 12y equals negative 13. Take away 77 from both sides would give me 12y equals negative 90. And so y will equal negative 7.5. Then I'm going to look at my equations and decide which one looks easiest to substitute into. I'm going to pick this one right over here. So x will equal 11 plus 2 times 7.5, negative 7.5. X will equal 11 minus 15, so x equals negative 4. So my mystery numbers are -4, -7.5. And again, these are the only two numbers, the only combination of mystery numbers that I can plug into these equations and have them be true statements. All right, well, hey, the next 9 are yours. Good luck. Oh, go ahead, get started. See you soon.